Good morning, and your student Dolphy Alexander Gilpin, president of the Amz5x12M matrix. Its derivatives, inputs and outputs, and applications. I'm here with you at 1524 LaVista Drive, Decatur, Georgia, on the second floor, and more specifically in the closet of the second floor. Now, synonymous or analogous or synonymous, comparatively, with pilots and astronauts having to work in confined spaces, example in the cabins, in the cockpits, in small spaces, spending long hours maneuvering the aircraft, 5-10 hours, sometimes on long flights, maneuvering aircrafts, astronauts even long time in space, in small spaces, confined spaces. This application of the Amz5x12M matrix is in very relative confined space, a closet, and here we are applying the Amz5x12M matrix in its versatility and multi-dimensionality to some aircraft problems. And what we have here now, we're starting off here with alpha being the angle of attack is equal to W0 over nu zero, where W was the vertical velocity and U was the longitudinal velocity, which is equal now to 0, and this is for trimming the aircraft. And the R rate now is equal to R is equal to G over the initial longitudinal velocity nu sub 0 times sine phi, and it's approximately equal now to G over U sub 0 phi, because the trigonometric identity sine phi is approximately equal to phi itself when phi is very small. That's high school trigonometry. And also that the yaw rate psi is equal to r. Now here we come to know some breakdown derivatives now. Matrices derivative from a 5x12. This is now 1, 2, 3, 4, 5, a 5x5 matrix, demonstrating the model in trimming the airplane. Augmented turning model using rear rudder, and the delta R here, the delta sub capital R, mean the using the rear rudder, R for rudder. And for this equation here now we have V dot, and these are some rate of change now that in respect to time, P dot, R dot, which is the R rate, psi dot and phi dot and psi dot is equal now to this 5x5. A11, A12, A13, A14, 0, A21, A22, A23, 00, A31, A32, A33, 00, 00000, and 00100. And that complete the elements now of this 5x5 matrix. And this is now times now V, P, R, psi, and phi. And this is now plus now B11, B21, B31, 0, and 0. And this is now the equation for the augmented turning model using the rear rudder, delta R. And so turning autopilots will use this now equation for turning using the rear rudder. We're just going to look at augmented bank to turn model using the aileron, and we'll signal that now as delta capital subcapital A, meaning turning using the aileron. So delta subcapital A turning using the aileron, and delta subcapital R, uppercase R, is turning using the rear rudder. So here we are now. This is a breakdown derivative for 5x12. In fact, this is in a dimension of 5 in terms of the columns, but in terms of the row, in terms of the row, it's 5, which is equal to our 5x12 row. But in terms of the columns, it's only 5. So it's a 5x5 here, square matrix. And this is the model used now for the rear rudder, using augmented turning using the rear rudder. So we're going to take a break and we'll come back now using augmented band to turn using the Aerolon Delta A. And once again, we are stipulating that we are working with the AMZ in confined spaces, synonymous or comparative now to pilots and astronauts working in confined spaces for long hours. This is just for a relatively shorter time, but this is the versatility or the versatile application of the Amz5x12 matrix and its breakdown derivatives in its multidimensional application. We'll take a break and we'll return now to the augmented turning using the Aerolon.